Pause this video and see if you can solve this calculus problem. Are you ready? Let's go. So we are given this function y x squared plus 1 to the power of x. We need to find dy dx, or the derivative of this. Okay, so the strategy is going to be logarithmic differentiation. Why? Because the exponent x, we need to bring it to the front, and we can do that so that it becomes a product, and we can do that by logarithmic differentiation. What that means, we're going to take ln on both sides, ln of y and ln of this, for this function, and then we are going to use the power rule of logs, where we can bring the x in before the ln. So now this looks like this. We're going to go ahead and differentiate both sides with respect to x. So on the left we have ln of y, so that is going to be, with respect of x, going to be implicit differentiation. So it's going to be 1 by divided by y. Ln of y is 1 over y, and then times y prime. That's just basically the chain rule, dy dx. So on the right hand side, of course, we have just a basic product rule. We are going to differentiate the x first, and then this we're going to write as a product, and then we're going to differentiate the ln x squared plus 1, and then write x as a product. Okay, so this gives us 1, and on the right hand side we have a chain rule happening. So we have x squared plus 1 is 1 over x squared plus 1 times, and this is going to be 2x. Okay, the x squared plus 1, when you apply the chain rule, is going to be 2x, the inner and the outer being this, and the inner being the x squared plus 1. So now we have ln x squared plus 1 plus 2x squared by x squared plus 1, which is the right hand side. On the left we have 1 over y though. Now we take the y and bring it to the other side by cross multiplication. So what we have now is y times this whole expression. Now we can substitute the value of y as the original being given x squared plus 1 to the power of x. So let's go and do that. So now we have dy dx, or the derivative of the function that we had, is this long expression here. So what is the meaning of this graphically? So let's just say there's a function which is the original function that looks like this, and then this graph is the derivative of that function. Notice that where the derivative is 0, our original graph, the slope is also 0. Okay, so derivative is just the slope of the original function at that point. As you can see on this part, the derivative is essentially going, our graph, our function is going up, so the derivative is increasing. But as our function becomes less steep, the derivative is becoming lesser and lesser, but it's still positive. And then out here, of course, 0, and then out here, notice that the original function is steeply rising, and then the derivative, the slope, is also increasing. Okay, all right. So if you have any questions, let me know in the comments below. I'll talk to you next video. Have a nice day. Bye.